Hello, hello! We are live. Welcome, welcome. Today is the second stream of this live stream session. My name is Andrei Viktorov, and yeah, welcome to the stream. Hello, hello. All right, so today's topic will be focused around AI. I will show you how to create a simple enemy logic. I will show you how to create a navigation mesh and also how to do the overall game logic. All right, so let's get started. By the way, can you hear me? I guess you should hear me. All right, so if you have any questions, feel free to ask and I will try to answer during the live stream. So don't hesitate to ask. All right, so let's get started. Okay, so during the last stream, we stopped on the simple shooting mechanics. I showed how to create a simple first-person setup, and another thing that we did is we put the whole project to the repository. So if you want to go and play with the what we had during the first live stream session, you can go to the repository and download it. And this tutorial will be also based around this project. So let me show you the link. So if you go to this link, you can just download the whole project and play with it. Okay. So I already downloaded this project, and the first thing that you want to do is to add it to the SDK browser. So the way you do it is basically go to the SDK browser, go to My Projects, add existing, and then browse to the project. So in my case, it will be in this path. But I already added it, so I don't have to do this one more time. So I added it here. All right, let's open the project and see what we have. But before I run the project, I need to adjust the editor so you can see it clearly. Like so. And yep. All right, can you see it? I think you should see it. Okay. All right. So this is what we get from the first live stream session. We had a simple first-person setup with animation blending and simple shooting. So I also fixed the missing textures that we had during the last stream. Hello, bro. Hi. So this is what we have now, and yeah, it's kind of fun, but I guess it will be much more fun if we will add enemies that will chase us during this level, in this level, and also it will be fun if we can win or lose. Okay, okay, let's prepare the content. So the first two things that we need to add is the bullet and enemy. So we have a bullet prefab that is located here. We imported it in the first live stream session, and now we need to fine tune it. So if you just drag it here, you won't see anything. It's because we didn't properly set up it. Let's go to the palette FBX and adjust the scale so we can see the model. Okay. And we also need to set mesh here, all right? And we also need to set the material. This one. All right, so yeah. And another thing is we want to disable intersections because we will do this in the script. All right, that's all we need from this prefab. So we are gonna use the same content that is from the third-person shooter demo. So what we're gonna do is we're going to basically import some content from the third-person shooter demo, such as robots and bullets. I think Engine is using BSP trees for bullet collision. Can I use Engine BSP tree like data structure with headless mode? It depends. If I'm not sure why it's taken too long to load the scenery. If it's because of the rendering and stuff, you can just run the engine in headless mode by passing video up, by setting video up to null. Basically, you won't have any window, but you will be able to run game logic. So we are going to use this prefab. That's what we need. We're not gonna use any scripts or something like that, just the content itself. And luckily, I already prepared the content. So let me just grab it from the folder. So here we have a robot, and we have everything we need to prepare the the prefab for the enemy. All right, we'll just copy it, wait until it will be imported, and here we go. All right, so what we need to do, one thing that we need to fix is to set the proper scale in the FBX file, and then hit re-import. All right, and we also need to do the same thing for the corresponding animations. All right. Okay. So now we have already prepared enemy material, and we have prepared enemy node. Let's just start from this and fix missing links here. We'll go to the edit, and then we will just fix these missing links. Go to robot and take the actually no, let's go to robot idle and grab its mesh. All right, yeah, that's better. And also let's grab the preview animation. All right, okay, that's nice. And another thing is that we also need to change the materials. Let's assign to the body the main material. Oh no, it's not for the body, it's for the this one. Yep, let's fix the glass color. And let's also assign the reflections, glass reflections. Okay. All right. Let's stop the animation, reset its time. We also need to set up a physics for this for the enemy, and we can do this in a few ways. The first way would be to just go to the object mesh skin and set up the physics here, like set up the rigid body and set up like collision capsule, like so. What's good about it is that we have everything in one place. What's not good about it is that right now we can change the visuals. For example, if we want to scale or add something else here, we can't do this because physics won't work with the scaled objects. At least it will scale it back. So this is not what we want, and instead we will do another approach. Let's get rid of this first. We are going to add another object dummy. Let's go to the create physics object dummy here. All right, let's reset its position, and let's move this as a child node. All right, so that way we will be. Let's also rename these two visuals. So that way we can control the visuals and the physical representation separately. Let's assign a body rigid here. Let's also assign a capsule. And let's 0.7, and here should not here should be 0.95. all right. I think like that. And we also need to scale this robot. Let's go to 0.5, I guess. So we need to match all the door frames. So we need the our enemy be able to go through this like tiny door frames. So that's why we need to adjust its size. All right, so let's go back to the physics and see. Maybe we can also reduce the radius a bit, like 0.2 maybe? No, 0.3? No, I guess 0.5 is good. Okay. Should be 85. Morning from Southern California. Good morning. How are you doing today? All right, so here is our prefab for the enemy. One more thing we need to do is we need. Okay, let me show you what will happen if we'll keep it as it is. Let's just simulate the physics. And if we rotate it like so, it will fall. That's not what we want. So we want to disable the rotation. And we can do so by... Hello from Russia, Volgograd. Hello, hello. We can do so by just setting this angular scale to 0 on all three axes. So that will disable the rotations. So that's what we want. Basically, we want it to be only we only want that the physics will affect the position of the rotation. Okay. So now we have an enemy prefab, Let's actually get rid of other nodes like this one. Okay. One more thing that we also need to do is if you had a look at this setup. So for like this mesh is a skin mesh, and for specific bones we can attach some sort of particle effects, but what we want to do is that we want to attach like no dummies at the weapon muzzles, so we will be able to spawn bullets. Okay, so how can we do this? We need to create an additional bone, an additional node. It's called where it is, skin bone, and we want to attach it to the, I know the joint names, but like if you will have like a real mesh, you should probably name these joints properly, so you will be able to easily see which bone is which. So in my case, joint 8 is the left gun, and joint 11 is the right gun. So let's rename this like right gun bone, and let's duplicate this. That's not the right, that's a left bone. Okay, left, yeah, and this will be right gun bone, and this should be attached to the joint 11. Okay, and two more things that we need to do is that we need to create a bunch of dummies, like dummy nodes, and just move it a bit, like, I don't know, like 0.8 maybe. Let's also reset the rotation. Yeah, that should do the trick. Okay, and let's call it left gun muzzle, and we'll do the same with the right gun. I will reset the position and then just set it again. Okay, so now we have two nodes from which we will spawn our bullets. So basically, when we want to shoot, we will just create this prefab from either this position, like this one, or this one. So that's how you can create the shooting effects. Okay, so we are done with the content. So we have bullet prefab, and we have another prefab like enemy prefab. Okay. What else? Now we want to start working on the AI actually. So the way we are going to implement the AI is we're gonna use a thing that's called finite state machine. It's a concept. It's basically it allows you to describe the logic in terms of states and transition between them. So basically what we're gonna do is we're gonna create a few states. Like, I'd say we will end up with 3 states, and in a big projects you will end up with much more. Usually you end up with much more. So each state has its own name, like idle, chase, and let's call it attack or fire. And in this diagram, basically what we want to do is we want to describe what this state is, and like what the enemy should do in each state, and how we can transition between different states. And what are the transitions? Like usually the typical transitions would be from idle to chase, from chase to attack, and vice versa. So these are transitions. And then we can describe, like in plain English, what we want to do in idle state, like do nothing. Or, I don't know, play some idle animations. Something like that. Or if you have like a more complex logic, you can just, I don't know, like do some like job, or go to random place, something like that. But in our case, we'll just stick to this. So this is the simplest state. In this state, we are going to move to the attack range, move close to the target, so we'll be within the attack radius or distance. And in this state, like attack fire, what we're gonna do is to just shoot. So, and once you figure out your states, the second step is to figure out how to transition between them. So, like if we do nothing, how can we transition from idle to chase state? Like idle to chase. So basically, we also can just describe this in plain English, like if the player is visible and come close, something like that. And the same thing we can go to like chase idle and like lost sight with the player of the player, something like that. And the same thing with these two states and these two transitions. If we want, we can later modify this finite state machine and add states like that. Like we can go directly from attack to idle, or we can, like, I don't know, like add another state, call it something like, I don't know, like warn state, and then let the enemy pick random points on the map and go and check them, something like that. But for the sake of this live stream, we will stick to these three states. All right, so let's go and implement them. So we are gonna to create a new C# component. We call it enemy logic. So we also try to keep it as modular as possible. So we'll probably split the enemy sensors from the enemy logic. Okay, so the first thing we need to do is we want to add enum like enemy logic state, which will describe in which states are available for this finite state machine. So idle, chase, and attack. So here we will add this state, let's initialize it to idle. And in the update section here, what we will do is that we'll just do like a big switch case. That's not the optimal way, but it will show you the idea. I will do every state in a separate function, just for the case of readability. Attack state. And we will add more public variables once we will need them. So let's also add this prototype like functions. Process idle state, process chase state, process attack state. Okay. And here we need to add the logic for the transitions. Like we also need to check idle chase transition here. And in this, we need to check chase to idle transition, as well as we also need to check chase to attack transition. And here we need to check attack to chase transition. So the way we will handle chase is that we will let our enemy remember our last scene position. Hey Anthony, how are you doing? So we'll keep a variable last scene position. And well, what we also need to check here is like if the fine, cool to see you there, thanks. So what we need to do is we need to calculate the distance between the enemy and the player. So for the enemy, we can like for this enemy, which will use this script, we can just use this node, like built-in node property or variable, and we will rely on world position. And here we need to add something. Basically, we need to know if we can see the player or not. So the one possible way to add it is we can add it here like so. And then just grab its world position. Like so. Or even that. It's basically distance squared. Just a faster way to check. We can, instead of checking distances, we can check the square of these distances, because this is much faster in terms of calculations. And here, if we come closer to the, let's say, chase radius, and we also add this variable as a public. Let's say if we came closer than 3 units, then current state should change to enemy logic state chase. Let's actually forget about this one for a minute. So this is basic like logic, and here, or actually let's not forget about it. Like here we need to remember the last scene position, like player world position. So another thing is that we need to actually chase or go to the last scene position. So the way we are going to do this is, well, we can do this two ways. First way is to just change the node position, like let's do this direction, last scene position minus node. Let's get a normalized version of it. So, and then we have a direction and we have a like some sort of a speed. And let's also set this as a public variable. I don't know, like 1 unit per second. And then make it frame independent, like so. Nice, I'm a start using Unigine. Yeah, why not? So that's the one way you can handle movement, but if you do it this way, you will completely ignore any collisions or physics, and that's not what we want. We want our enemy to interact with the physical world. Wait, does Unigine support 2D? It's a 3D engine. I mean, you can do 2D stuff in 3D engines, but like if you want to focus on 2D games only, I'm not sure if using a 3D engine is a good idea. All right. So, as I said, this way might be nice for like a simple game when you don't need any collisions or something like that, or just for a quick prototyping, just to check if like your logic works properly. But what we do instead is we will use the physical body to move the enemy, and let's call it body rigid. And in the init section, we will set this body rigid to this field. So the way this field works is that it checks if this node is an object, and then it also checks if this object has a body rigid, like has a rigid body set to this object. So in our case that is true. Yeah, let's wait, because we are going to assign this script not to the bullet to this robot root, and robot root is an object dummy, so it's an object. And then it also contains rigid body, so that's what we need. So, and then we will move this node according to the physics. All right, so the way we want to move this body, is it difficult to configure CI for the engine? By CI you mean continuous integration? If so, then it's mostly about like, let me show you. So basically you have like Visual Studio project. You can either use console like .NET fix build, and that way you can automate the build process. As the output, you will have this executable. What it is, like FPS demo. So you can push it to like as an artifact or something like that, or just check if the project health is good or not. Did I answer to your question? Okay, thanks. All right, so let's continue. Let's get back to our enemy logic. So instead of directly setting node position, we will use body rigid linear velocity. So we'll just set it to direction times speed. So that way the node will always try to move to the direction to the target, and yeah, basically that's what we need. And it will, that way it will also react to the physical world. So it might not be always true that if you want to, do not expect it to be exactly to the position you wanted it to be because of the interactions with the physical world. Okay, so this is like very basic movement. And one more thing is that if you set the velocity that way, then you will ignore gravity, because the way physics works, it applies forces, then it calculates the acceleration, then it calculates the velocity. And if you set or set your own value to the z coordinate, that basically means that you are ignoring gravity and every external forces that might affect like the z coordinate of this node. So what we're gonna do is, first we want to cache the current velocity, like body rigid, like so. Then we only want to modify the horizontal component and keep the vertical component as it is. So that way we will keep gravity in the velocity. Okay, so this is like very simple chase. So this assumes that there is like a straight line between the last seen position and the enemy. So if there is some sort of an obstacle, or if the enemy was moved and like between the last seen position and enemy, like there is some obstacle, it will stuck basically. But that's okay for now. We'll fix that later. Okay, so how do we need to transition back to the idle? So first of all, we need to check if the target is reached, right? So first, let's also have some breach radius, and let's keep it small, like 2.2f. So the way we want to check this is, let's modify this code a bit. So we want to check the length, or again square distance between the last seen position and the check of breach radius. So if it's within this radius, then basically we think that the target is reached, and we don't need to do any of this. And if target is not reached, then we would like to move, or if it's reached, we just want to set the velocity to 0. And here, if target reached and something else, we can transition back to the idle state. And this check, we will do it later, like is target visible? Let's call it false. So we'll do it. So basically, once we reach our target, we need to also check that if we can see the target, if we still see the target, we need to update last seen position, and we need to keep chasing, basically. If we reach the last seen position and the target is not visible, then we're gonna go back to the idle state. So it's that simple. And here, what we need to check is, let's distance. Let's do this and then normalize. Basically, if we are within attack radius, and target visible, then we can transition to the attack state. And here we need to add the foreign logic. We will do it later. What we need to do is we need to add the transition back to the chase state. Again, we need to check if we can see the target, and we also need to check the distance. Like last seen position and our current position. So if the target went like attack and radius, or let's call it max radius. So basically, if target went outside, then we transition back to the chase state. Actually, or if we lost sight, is target visible. So either this or that. So we will go back to chase state. And we need to add these two radiuses. So the reason why we add in two radiuses is because let's imagine that this is our scenery, this is our target, and let me put it as a red, and this is our enemy, like so. Also, let's imagine that I don't know, like the fire radius is this, like, so the target comes closer to the attack range, so we transition to the attack state, and then on the next frame the target went outside. And so in order to remove the transition back and forth between chase and attack states, we want to add 2 radiuses. So once we are in the attack state, we will keep firing until the target reaches the outer radius. So that's why we need these 2 radiuses. Like, that's actually called inner and outer. That's a better name. Okay. Let's call it like okay, and the outer radius will be like 7. Okay, so what we need to do is we need to add these checks, like how can we see if like how can we check if the target is visible or not. And the way we will do this is basically the same that we did with the shooting during the previous live stream session. So let's just copy it. So here we'll just copy this, maybe this, yeah, and also add specific function like private bool is target visible, and here for the P0 it will be node world position, and for the P1 it will be player world position. So world intersection, probably don't need any information right now, so we can get rid of this. So the only thing we need to do is we need to check the intersection and mask. Let's just think that we will check everything. So return let's compare the IDs. So if we hit the same thing like the player, then like if the player and like between the enemy and the player is a clear line, then the target is visible. Actually, this is not the most correct way, because that will only check like from the center of the enemy node to the center of the player, and that in some cases it's not enough to do so. And again, for the sake of this live stream session, we will keep it as it is, like so. Another thing is that in both scenarios we want to remember if we still see the target, then we want to update last seen position. Like player world position. And the same here. And as you might already notice, we have a lot of like the same logic here. Later on, we can move this to another component, and we can call it like enemy sensors or something like that, and we can rely on the information from that sensors in this logic. So the logic will be very simple, like it will get any information from the sensors and then decide which state it should be in. Okay, so let's... What else can we do is... another thing is... maybe we should split the logic and the movement and the checks. Let's do this. Like when we want to transition to attack, we still want to, I don't know, like keep moving to the, or we want to stop in this attack range. Let's do this. So let's assign the velocity here, and here we will just, again, current velocity, we'll set the velocity to 0, like so. Okay, that way, regardless of the, and let's actually reset it here. So by default, we will have 0 velocity, so we don't have to put it everywhere. And if the target is not reached, we will move to the target. If not, actually we still need to reset this, like when we want to transition to any of the attack or idle state. Okay. Let's actually go and test all, like everything we wrote right now. One more thing that we want to do is that maybe we want to debug the state transitions, just to understand what's happening. And in order to do so, we can do this thing. We can use like a visualizer for that. Let's do another switch case, and here we will use visualizer, render point 3D. We will basically render the point above the enemy with different colors. So here we need to take node world position plus up, and size would be 0.25, and the color would be like, let's call it blue, not black. Okay. Here we want to do the same but with different color. Actually, let's do this. Chase will be yellow and attack will be red. So that way we will know. And what else can we visualize is we can visualize a sphere with different radiuses, like chase radius, node world transform, color vec4 yellow, attack inner, and attack outer. Something like that. Let's assign this script to the enemy logic, and here we need to add a player node. Hello Frovrik. I've been invited to teach people how to do stuff in Unigine, so that's why. That's how. Let me just do a few sips and then we will continue. All right. Let's think that actually, let's move this first person setup outside, delete this node reference, and the enemy will, let's call it player. The enemy will try to get to the player. Oh, one more thing, we also might want to actually line 35. Player is null. Oh, of course. This. Or maybe we can simplify this. If fit object is null, then we will definitely can't see the player. And if it's not null, we will compare the node IDs. Okay. Right now we can see the state blue. It means it's in the idle state, and when we reach a yellow radius, then nothing's happened. Okay, then that's definitely not the way it should work, and well, we already knew where to look because we know it's in the idle state and we are within the chase radius. So something's wrong with this in the idle state with this logic. So we compare distance between enemy and the player, that's okay. We also calculate the chase radius, that's also okay. And we compare in these two things. Oh, no. It's a bug in our visualization system. Okay. One more thing that we might want to render is slots in position. Let's mark it as a magenta. Okay. Okay, so it remembers. So it's in the chase state right now. But again, as we see, it's not updating our last seen position, which it should be doing. So then we can go to the chase state, and then last seen position, player. And again, we can visualize that. We can visualize this. Let's move it a little bit. And here, if we is player visible, then we can go with this. Otherwise, red. Is target visible, not the player. Okay. And then we will run it again. And it can't see the player like at all. It's always red, so something's wrong with this check. Okay, so we are... Oh, I see what's wrong. So the thing is that it starts the raycast from there, and it's always checks with the ground floor or something else. Okay. Another thing that might go wrong is that the intersection check will intersect with the robot itself. So we want to disable intersections here. Or no. We probably might want to do different intersection masks, not the because we still want that our bullets hit the surface of the enemy. All right, so what we are gonna do is basically the most simple way to fix this is to assign a specific mask to the player, like physics intersection mask. Should be somewhere else. Auto stepping debug. Yeah, okay. So we'll probably assign these to, I don't know, let's assign this to this bit 16. And then okay, then we need to set the same mask parameter to this check. So we will probably move the mask parameter to the public variable, like so. Like player intersection mask. And here we will use this. So in the enemy logic, we are gonna fix this here. Yeah, to the 16. Now let's see. still it can't see anything. Let's just print the name of the object. Like so. Yeah, so it doesn't hit anything. This is 16. And this also checks 16. Okay. Let's go inside the first person controller and see like the physics intersection mask. Yeah. Yeah, so the shape works correctly. So, yeah, it's adding the body. Let's try to test the like the all masks and see if it will work. No, it still can't intersect with anything. Why is that? Let's also visualize our points, just to be sure that they are in the correct positions. Render vector P0, P1, black 4, black. Just to see where it's looking. So it's looking directly at the player, and yeah, from the ground. So the problem is that it probably hit the ground. Yeah, floor gray. So object name is the floor gray. So probably instead of world, we can go physics. Get intersection, yeah. And yeah. And let's see if we have what we need. Okay, so instead of doing world intersection with the surfaces, we want to check intersection with the player collision shape. So that's what we want to do. And here, let's just go to the physics intersection. Let's test it like so, or just go with like that, hit info. Okay. So right now, everything should be fine. So we We can only check if we can see the player. And the other problem is that if we only check the player mask here, then if we'll be behind the wall, for example, like the enemy will still be able to see it. So we also need to check from the proper place. So we definitely want to skip the enemy itself, and we want to check with the other obstacles. So how we're going to do this? First of all, let's just test if the physics intersection works. Like so. Player, and let's clear this and hit 16, and in the player we still assign to 16. Okay. Yeah, so now it's almost working like how we want it to be. So basically right now it's in the idle state, it can see the player. Not sure why it's flashing like that. We'll figure that out. So when we enter the chase radius, it will follow to the last seen position, which is correct. And right now it's in the attack state. And once we will go outside this radius, like the outer radius, it should attack us. It should stop following. Like it should go to the... Make sure low-end PCs or laptops can play it. Yeah. So it will follow to the last seen position, and then it should stop. Switch to idle. Yeah. Okay, so we need to figure out the visibility check, and other than that, it seems that it's working pretty nice. So let's figure out these intersection checks. Good luck on making it, bro. Thanks. Okay, so what we want to check, let's first so most of these also have, no, they all have physics interaction disabled, and this thing has only intersection mask 16, and the robot also checks only intersection mask 16. Okay, so that seems really weird to me, but probably just, yeah, probably this phrase not too long. Let's do it like so. position, and then we will just move it a little bit further, like distance. Not distance, direction. Let's see if that will work. So it seems that it still hits the ground. So let's see if... No, it doesn't have any physical intersections. And this one also. It still has collision, but that should be fine. All right, so let's design back to the world intersection. And then here we'll also have world get intersection, hid info. And here, let's actually do like a let's actually instead of pointing it directly to the bottom, let's point it near the hands. I guess that might work better, like so, to the camera. And then physics. Let's see. This should work fine now. So the reason why we can't see this vector because it's pointing directly at us. Okay, so let's get back to world intersection. And the way we fix this is actually we are going to make a quick and dirty hack. So we'll put a primitive, like a box primitive, we'll create a virtual hitbox. 0.2, 0.2, 0.2. We'll put it to the camera, like so. We'll make it invisible. We also disable any intersection. Actually, we will enable intersections. And this mask, like player visibility box, and then we will add it to here just to see if it works the way we want. Yep. And the problem right now is that it can see us through the walls, but we can fix that. Okay, so we'll set the visibility box mask back to the default mask, and here we'll also set it to the default mask. And in this intersection there is a specific method which will allow you to exclude nodes. So what we want to exclude is that we want to exclude our node, let's do it like so. And this thing. Any chance migrate the game without coding? Probably not. And here we'll just add this node. Hit excludes. Okay. That should do it. Yeah, so the trickiest part is the visibility check, I guess. Yeah, so now it intersects with the floor, but that's fine. What we need to do is that we need to move this a little, like to some sort of offset, or just add a specific dummy to the enemy from which it can do the intersection checks. Okay. Let's add this. We can add this to visuals. This is the root joint, I guess. How long you are working on this one? What do you mean? So like the stream is going an hour and a half, and yeah, I guess we need like 1 more hour to finish what I want to show you during this live stream session. Okay, so we're going to create additional dummy here, and that's cool. Yeah, thanks. Robot intersection. Like socket, and we'll move it just right here. Okay, and then we also add this thing, and here we'll just use it. Yep. Okay, that should do it. Yeah. And it seems it's not there for some reason. Should be there. Okay. It seems that we need to manually re-import that. No. Still no. What if we do this? No. Okay, it seems that we have a bug. Okay, let's work around it. Man, you're a wizard. I mean, it's cool to see how you make it so easy, especially for me as a layman. Besides how it looked like one day. It's actually this like the second episode of the whole series. For some reason, it doesn't want to add my property here. What if I break something? Nothing's happened. Let's close it and run again. Yeah. All right. Let's see if we have no. Still no. Please. Yeah. Finally. Okay. It's here. Okay. That's better. Let's see. So right now it intersects with the visuals here, and that's not what we want. We probably need to add 2 more nodes, like heat excludes get child. That's okay because like this robot has only visuals as a child, so we will ignore it as well. And finally, it should work as intended. Yeah, player visibility box. So right now, it sees what it should be seeing. And if we go behind the wall, so it's red, now it's green. Yeah, so okay, so finally it's working just fine. Oh, oh wow. Yeah, so yeah, probably should move the visualization away. Okay, maybe like yeah, and we can just move visibility box a little bit below the player. Yep. Okay. Finally. So it's in the chase state, so it's updating our position. It's funny how we can break his line of sight by just looking down, because it will intersect with the I don't know, with the skin mesh of the gun. But so it's in a chase state, and that's good. So here's the last scene position, and it will be probably stuck. Yeah, so it's stuck, and right now it tries to reach this target, and it's the enemy still in the chase state, and that's fine. That's right now it transitioned to the fire state. Here it still can see us, and yeah, once I reach the outer radius, it will try to chase us. So when I go out, it will again re-enter to the chase state, and once it will reach this target, it should be back to idle state. No, it's okay. So basically that's how you do simple logic, and what we need to do else is that we need to add rotations to the enemy so it will be pointed towards us. And another thing that we need to do is the defining logic. So let's do this finally. Okay, so let's remove the actually no, let's keep it as it is, and yeah, good to go. Have a nice rest of the day. I'm gonna check the first part. See you next time. Yeah, thank you for coming. Have a nice day. Okay, so now it's the interesting part. Let's fix the orientation. Let's do this. Let's move this update last visible position logic outside these two states and make it like in a separate function, like so. Update last seen position. Hi bro, love from India. Hello, hello. Let's do this, and then player world position, and this thing here. Okay, so how are we going? Good. So this thing will be updating regardless of the current logic state. Basically it will be our, like, the enemy eyes. So it will constantly check if the target is visible, and if it's visible it will update last seen position. So we don't have to do it in any of these states. And another thing is that let's actually do the this check. Let's initialize it to false, and here we'll do it like so. So we don't have to like check it every time in the states here. Okay. Like so. It will simplify our logic, like target is visible, target is visible. Yeah. So yeah, it's and we probably also need to calculate distance to the target and direction to the target. and we'll call it update target state. Last seen direction will be player, like last seen position minus player world position. Last seen distance squared is this thing. Yeah. And another thing is the direction. Yeah, okay. That's good. Right, so this function will update everything we need. It will update the direction to the last seen position, it will update the distance to the last seen position, and it will also update if we can see the target. Basically, this thing will now become like the enemy sensor with all the corresponding data. So we don't need to check this, for example. We can just use this last seen distance. We also don't need to check this. We can see if the target is reached here, and direction, let's normalize it here. Here and also here, and we also don't need this anymore. Last seen distance. Okay, so it's now becomes even simpler. So it's go to the last seen position. If we don't reach the target yet, we continue moving to this target. If we lost sight with the target, we transition to the idle state. Yeah, and here we probably won't need to is target visible. Like target is visible. Yeah, so if we come close to this radius and the target is visible, we transition to the chase. If we can see it, we don't transition to the chase state. And here, if we lost sight, we transition back to idle. That's fine. If we went into attack range, then we go to the attack state. And here, again, if we lost sight, we can transition to idle, for example. Like attack to idle. Or no. We'll go to the chase state. Yeah, if we lost sight, because we want to come closer to the last seen position. Yeah, okay, so that's fine. Let's test it one more time, and then we will do the shooting logic. Okay, so right now it's in the attack state. Oh, yeah. That's why. It was a mistake. How you going? Pretty good so far. We are almost done with the enemy logic, and like we only need to do like the navigation and game state management, and then the shooting as well. So right now it's in the chase state, and that's the last position it saw us. That's good. And it stopped moving. So it's in the idle state. If I go to the, so it's in the attack state right now. And minimap, no minimap during this live stream. So it's in the chase. No, it's in the attack because I came closer. That's correct. And when I go outside, it should transition to chase state. Yeah, that's correct. Yeah, this is probably not correct, because it still needs to reach the target and then and only then check. Yeah, I need to do this, because we only need to perform this check only when we reach the target. Yeah, okay. Now it should work perfectly, I guess. Let's see. Now it's in the attack state. Now it's in the chase state. Even though if it will lose line of sight, it will still be in the chase state. Yeah, let's hide. Yeah, so it's slowly moving. Now if it will see me again, it will update last in position and then move to the... Yeah, so it's in a chase state again. So the last in position is here, and it will be... Yeah, it's stuck. Oh. Okay, so let's add orientation, and then we will also add shooting. So the way we handle orientation, we will always be looking to the last in position. Private void update orientation. So the way we handle this is just we will modify node world rotation. Like so. So here we need to set something, and we're going to first of all we need to calculate the target rotation. That's very simple. It's the leap set2 rotation. So the position is node world position. The target is last seen position. The up vector is up. The axis should be Y. And the current rotation is this. So we need to update current rotation somehow and then set it back. That's what we're gonna do. And we will do a very simple trick for this. We'll just do a slurp and the current rotation and then target rotation, and then we will just do this thing like rotation stiffness, I would say. Let's put it as 8. So the bigger this value is, the faster the current rotation move closer to the target rotation. So let's see if it will work. So what's... Oh, okay, it's because... Can I do it like so? Okay. Can I do it like so? Okay, let me just check the how I did it in the sandbox project. Oops. Oh yeah, so basically this. Yeah, of course. Yep. And yeah, we need to... Andre, are you planning an analog of blueprints for Unigine? Not sure about that, so better to ask devs. I guess you can go to Unigine Discord and then ask them directly. Okay, so... Okay, that's what we need. With a few exceptions. We don't want it to look up. Yeah. Okay, so let's explore direction. Let's see in direction. Direction z equals 0. And then we can simplify this. We can set the position, the vector here to 0, and instead of position we can use this direction normalized. Hi, hello, hello. Welcome to the stream. Yep. And then I guess it should work. Yeah, okay. Okay, perfect. Yeah, it's still in the chase state because it can't reach the target on the, because it's above the enemy. Yeah, cool, thanks. Okay, so now it's becoming more and more fun. Let's do the shooting. Okay, enemy, fire, controller. And here, what we're gonna do is, first of all, we need to add the link to the prefab. And we also need to add a position from where the builds should be spawned. So let's do this. Node dummy, left muzzle. Actually, we can use just node. Don't have to use only dummy node. Right muzzle, and then we need to set a prefab here, and we also need to specify. And on this engine, can you make a first-person shooter? That's what we are doing right now. Parameter file. Yeah. Basically, that should be it. And what else do we need to do is we want to add a shoot interval, like 1 second, and then keep the current time. So in the init section, we will just reset the time once again, just to be sure. And here, it will be very simple script. Game.ifps if current time is more than shoot interval, then we'll reset it and we'll spawn bullet. Again, we will use a load node here, and here we need to set the transform, and we have left. And are you adding audio also? We will do this on the third stream. So this stream will be mostly focused about how to do finite state machine for the enemy, how to debug it, how to do like debug visualization, how to create a navigation mesh, and how to like implement the game state and transition between different game states, because it's also a finite state machine. So here we need to assign it to something, and we have 2 muzzles. Let's keep it as it is, like is left. Okay, so that's probably all we need to do. And one more thing is so if we are not firing, then we should probably do nothing. And we also need to add a few public methods, like so, like start firing, and its firing should be set to true, and the current time should be set to shoot interval, just because we want to fire immediately. Or maybe maybe no. Just set the boolean here. Stop firing. We can design this the other way, like we can set the boolean directly and make it like public property or something. But it's better to have like a clear interface how the other components can interact with each other. And here we can later add like more complex logic, like I don't know, like if it's jammed, we can't start firing or something like that. Or we can also notify the audio system, or I don't know, like make an additional effects or something like that. So it's better to have a separate two separate methods in our case. And then let's go to the enemy logic, and here we'll just grab this component, private enemy fire controller, and in the init section we'll just grab it. Fire control, like so. Okay, so and here if we have the controller, we can start firing, and here we can stop firing. Yep, so that's it. Very simple. Okay. Oh wow. It's crashed. Okay. So now it's compiled, and let's add the enemy fire controller, and let's add two muzzles, left gun muzzle and right gun muzzle. And for the bullet prefab, we gonna use bullet. Shoot interval 1 second, should be fine. Let's test, and it will probably not work as we wanted. It will create prefabs, but as you can see. Oh, another thing is that we only shoot from the left. We are making a PC game, and here when we actually fired, is left should be, it's not left, like so. So we will fire from different positions. Right now, what else do we need to do is we need to actually modify the bullet prefab here. Let's go inside bullet prefab. So we want to bullet actually move, and the way we're going to do is we're going to create another component. We call it bullet. Yep. Okay. So what we need to do is we need to add a speed variable, like 10. Also later we need to add damage. Again, we need to add intersection mask. By default it will intersect with everything. Let's set it as a parameter mask. And we also need to do the heat prefab. Okay, so here we will cache world intersection heat info. And here we'll do very simple thing. So first of all, we will get the world direction of this node. Get world direction axis y. The reason we take y-axis is because it's considered to be a forward direction in Unigine. We also need to cache the old position, and the way we are going to change the node transformation is we're going to directly affect world like node position. Like so. Let's call it current position. We are going to do this thing. Current direction times speed times game IFPS. So it's the same way I suggested that we can move the object when we were designing the enemy logic. Okay, so what else do we need to do? The most important thing is that we gonna check the intersection between the current position of the node and the updated position. And then we go to we will also pass intersection mask, and we also pass heat info. So if we didn't intersect with anything, we can just do nothing because we already updated the node position, and that's fine. If we actually have intersection, then we will spawn heat effect. And then heat effect world position, heat info point, heat effect set world direction, heat info normal, and that would be an up vector, and the forward direction should be again y. Another thing we can do is we can apply impulse to the physical objects, but we can do this later. And the last thing we need to do is that we need to delete the bullet. And here we also need to apply damage. We'll do that later. Okay. So let's add a bullet here. Heat prefab, we already have it. Heat. And one more thing that we want to do is we want to add the lifetime. So for example, we don't want our bullet to live forever. Let's say we will destroy them after 5 seconds. Okay. Let's run and test. Now we have a shooting mechanics. Okay. So right now, if we go like inside the building, for example, so the enemy won't be able to chase us because it only knows the last in position and it can't traverse properly to this position. Let's say it's like the enemy saw us, I don't know, like here, and it might get stuck or something like that. And instead, what we want to do is we want to use pathfinding in order to like have a better experience and like give the ability to like give the additional knowledge to the enemy about how it can navigate throughout the level. All right, so how we are going to do this? Can I follow this tutorial with C++? Yeah, of course. You can create a C++ based project and create a C++ code, and yeah. But another thing that you make to be sure is that you need to go and read the documentation, because the C++ component system is somewhat different from the C# component system. So it has its own specifics. So yeah, you might want to go and read the documentation first. Okay, so now goes the interesting part. So the typical workflow for the pathfinding is that we need to provide some sort of a navigation mesh to this level. And the way you typically do it is that there is some sort of a bake navigation mesh inside the editor, and then you just bake the navigation mesh and that's it. So since we don't have this tool, we are going to do it manually, and I will show you how to do this. So first of all, we need to export all this scene to FBX. It might seem that this workflow is like redundant or too heavy, but actually it gives you additional control over your navigation mesh. So let me show you. So first of all, we need to select these clusters, like the buildings and stuff, and then we want to export them to Unity mesh file first. So we have exported mesh. You can try and export directly to FBX, but if you can't see anything, you can just go and export to the mesh first. Let me create another folder like nav mesh import export, and let me put this exported mesh to here. So basically we have the same mesh here, and we don't care about anything with this exception except geometry basically. And here we can export this to FBX. Okay, so now this should do the trick. Again, the exported FBX is quite good. Actually, let's not do this because I messed up the pivot position. So let's just put it to the center of the coordinates and then hit export FBX. Again, we don't care about materials or textures or anything like that. We only care about geometry, because that's what we will need for the nav mesh generator. Okay, So now we can delete this exported mesh. Let's just put the FBX just to see that it's good. Yeah, it's good. Okay, let's enable back the static content. And now we are going to open up your GCC tool. In my case, it will be Blender. In your case, it could be 3ds Max or any other external tool that will allow you bake navigation mesh. So for Blender, there is a specific plugin which is called Recast Blender add-on. Let me give you the link to the repository. This one. So I already enabled it. I'm not going into details on how to use Blender, but basically you go to the preferences, go to the add-ons, and then hit install, and then enable it here. So let me just, yeah, so I have it here. So basically it's a simple wrapper around Recast library. Recast is the like most known library for nav mesh generation. It's used across multiple engines, not only like in Unity. It's used in Godot. Let me check. So it's used in the where it's used, I guess. So yeah, it's used in most of the nowadays game engines for nav mesh generation. Okay, so let's import our FBX. FPS repo, data, nav mesh export. So we'll use this. So the way you are going to generate navigation mesh here is basically you can select the exported mesh and then go to the scene tab and then just use the you can adjust recast parameters here and just hit build navigation mesh. Congrats, you have a navigation mesh here. And the cool thing about it is that, for example, you have direct access on the navigation mesh geometry, so you can modify it. So you can just clean it up like so. Or if you are not satisfied with the like generation results, you can just adjust the parameters and then hit regenerate. So for example, if you can see, it didn't generate navigation mesh here. So I will probably need to adjust some parameters, and it will also didn't generate navigation mesh here. So for the sake of the saving time, I've prepared the same scene with the navigation mesh generated in Blender. Let me show you. It's basically the same geometry and the same navigation mesh, but different parameters. Let me just show it to you. So this one. Again, as you can see, it is the same geometry, but a little bit different navigation mesh. I already cleaned it up a little bit. And another thing what I did is I also cleaned up the geometry. And that's the cool part of it, because like you have the access to exact geometry, you can do whatever you want with it. For example, I remove the steps from every ladder and just keep them as a simple slopes. That will simplify the nav mesh generation. And this is what we have. This is the result of the generation. Not perfect, but it's fine for our case. And if you want more, you can just play with the recast parameters here, or even you can go and just re-edit what you have here. But it should do the trick for us. So that's the cool thing about it. And the workflow is if you update the geometry here, you can export it and then just regenerate it here. Or once you establish the basic geometry here, you can just export it in like a single time and then import it to Blender or any other DCC tool which is capable of generating navigation mesh, and then you can just generate and work with a navigation mesh here and iterate very quickly. For example, if you don't like this small hole here, you can just go and directly modify the vertices or edges. Something like that. Let me disable sniping. Like so. And let's export this navigation mesh and go to our project. Let's create another folder. Let's call it nav mesh import. Hi, I'm from Indonesia. Hello. And we only need to export selected object, and we only need mesh. Nav mesh. Okay, let's go back to Unigine. Okay, so here we have our navigation mesh. Let's fix the default scale. And let's create the navigation system. So the way in Unigine there is a specific node for navigation. There is two types of navigation. You can define either navigation sector, it's like a simple box, or you can use a navigation mesh. And you can connect between each other. You can connect multiple navigations with each other, and that way you can build your navigation throughout the level. So let's select the nav mesh that we just exported. Oh, it's wrong. Yeah, let me re-export it. It's a wrong orientation. So let's export it like forward. Why? Forward the up. Yeah. Let's create it again. Navigation mesh. Yeah. Okay. Yep, here we go. So this is our navigation mesh for this level. Let's set it a little bit higher. Yep, so that should work. And yeah, you can see this navigation here. So this is what we are going to use for a pathfinding algorithm. Okay. So what we need to do is basically we need to modify the enemy logic. When we are in the chase state, instead of going directly to the last seen target, we want to have some sort of a path which we can follow. And that's what we are going to do. Okay. So let's start working on that. And then we can work on the game state, and I think that will be it for this live stream session, because I guess we are running out of time. Let me check this thing. Yep. Okay. So first of all, what we need to do is we need to add a link to navigation mesh. Okay. What else? Then there is a specific thing which is called path root. Then we also need to, basically the way we are going to work with it is that this path root is capable of do the pathfinding calculation, and once it's calculated we can use its points. But instead we are gonna to cache the points into the queue. Like, let's call it calculated root, like so. Yep. So in the init section we can set a specific parameters for the root, like for the agent that is going to calculate its path in the navigation mesh. So we can, let's disable radius, but in some cases you might want to use radius, but in our case we're fine with it, without it. So this defines the maximum amount of like the agent height, and this is defined basically the maximum angle between navigation mesh polygons. So we can exclude some very steep slopes. Okay. What else do we need? We also need a bool variable here. Should update root. Or true. Okay, so what we're gonna do is we are gonna write another method like update root. Yep. And here, if we should update root, what we're gonna do is we're gonna do this root create 2D. 2D means that we want it to stick to the ground. That's what we want. So P0 would be the node position. P1 would be the last scene position. And here, basically here we are querying the, starting the calculation, and it might not be ready like instantly. Instead, what we want to check is actually if we already updating it, we don't want to update it one more time. Here, if it's ready, then we are still not good to go. We also need to check if it's reached the target. If it's reached the target, then we have all the root points. And here we will clear our queue and just add all root points to the queue. Like so. There is a one more trick, because the calculated route starts from the position of the enemy. We might want to skip the first point because we don't need to reach it. So we're going to calculate it like so. And if it's not reached, then we will recalculate it. Like so. So that's basically it. That's how we traverse our, like, not traverse, but that's how we get the root points. And let's actually visualize it. For each root point, size should be 0.25, that's okay, or maybe 0.1. I for last parameter beta plus plus I. Doesn't matter at this point. It's the matter of choice. In terms of performance, you won't gain anything about it. So yeah, the matter of choice. But yeah, I also prefer to type it like plus plus I, like so. But for the newcomers or for the like not experienced developers, this is more familiar. Okay, so we will visualize them as the black points. Okay, let's see. I feel like a noob because of that now. Don't worry about it. So it's fine. It's fine. You shouldn't be worried about it. So it's completely fine. Especially in that simple loops, it won't give you any performance gain. So don't worry about it too much. Okay, so let's see how this thing works. Will it work at all? We'll figure out. And no black points at all. Could be too high. Let's keep it maybe like so. And also let's move it a little bit down. So it will be definitely inside the navigation mesh. Oh, one more thing is that once we calculated this route, we should update it. Like, yeah. Okay. Should update. Why did he stop behind the corner suddenly? Because it remembers last seen position and then it moves to the last seen position, and once the enemy reached it, it perform another like visibility check and see if it can see us again. If the enemy can't see, it switches back to the idle state. Okay, so should update root. We can set this to true. Update root here. And that should be more than enough. Let's do it like that, and let's move it a little bit above the ground and see if we can see anything. And I guess we also want to remove this. Yeah, so yeah, finally we can see the root points. Oh, I know the problem. Yeah, so it's not the problem, but let's just create it to the player, just to see we like the pathfinding works. Yeah, so here are the points. So if we go behind the corner, yeah, it creates additional points. Yep. If we go inside, yeah, so it started to create like very complex routes. Yeah, okay. Yeah, so it works just fine. Yep. All right, so the pathfinding seems to be working. The last thing we need to do is we need to, like, our enemy be able to traverse this calculated route. So instead of so here what we can do is that if let's change the naming convention here, because for some reason I named it differently. Okay, so in order to make the enemy be able to transition or like traverse this calculated path, what we're gonna do, first of all, we want to calculate the distance to target. Again, here, distance to target, which is if the calculated route count, if it contains something, then we want to check if we reached it. Calculated route. We will grab the closest point, and then we will see check the distance. Like node world position length 2. distance to target squared, and if target is reached, then we will just remove this point. And the cool thing, if we still have points, actually let's distance to target. Let's say we want to check only horizontal. No. Let's do this, because we have different levels, so we don't want to perform like only horizontal checks, so we want to perform a full check here. Okay. Here, what we want to do is we want to calculate direction here, which is calculated root the last point minus world position, and then we want it to be normalized, but first we need to make it horizontal. Yep. And that's it, basically. Instead of going directly to the last scene position, we will go to the last, like to the closest point in the calculated route, and that's it. That's how you do path traversing. We don't have to change anything else, basically. So if we don't have any targets here, it will basically stop. Or if it won't find any path, this check won't go, this check also won't work. And also, if we can't see the target, and if there is no path here, we can check back to, like, we can transition back to idle, which is fine. And actually, I guess we don't need to do this here. All right, so let's try and see if it will be able to chase us on the multiple levels. So the problem is that the bridge radius is too low. Let's put it to 1. No, still too low. Let's set it to, I don't know, like 2. Yep. And for some reason it's still too low. Okay, let's set it to some I don't know, like extreme values. What if we go here? Seems that it's stuck. If we move navigation mesh a bit. Yeah, it transitioned to the ideal state. Yeah, let's not do this. Yep, that should, let's disable this for a moment. I just want it to chase me like throughout for the whole map. Yep. Seems it's stuck. Yeah, so the route is calculated very quickly. We need to add some sort of a delay because yeah, so it's not sure which way to go. Okay, so let's add a delay. Again, here public float route recalculation interval. Let's say every 3 seconds. Like last calculation time. And here we will be relying on the time. So here, if the game time was last calculation time, is less than √3 calculation interval, then we'll do nothing, and we'll only update it here once we actually calculate it. The root here. And there is an additional parameter here which can help us. It's called delay. It tells the pathfinding system that it's not necessary to rush and calculate the path immediately. So that's what we're gonna use too. Okay, let's see how it plays. Yep, so every 3 seconds it will update. Yeah, and we probably need to reduce the bridge radius back to, I don't know, like 0.2, I guess. Because right now it's set to extreme value. Okay, where is, yeah, let's in position, that's okay. And yeah, so can you upload sample work to GitHub somewhere else at the end of the lesson? Yeah, of course, it will be on the GitHub. The first live stream session is already on the GitHub. And yeah, I will give you the link, and I think the link will be probably in the description below after the live stream session. So yeah, it will be on the it will not be located on GitHub, it will be on GitLab. Okay, so we need to fine tune this bridge radius. Thank you, have a nice lesson. Thank you too. Yep, so it's following. Will you guys make a live stream to make a UI for any project game in Community Edition? Probably. Yeah, so it's still... Yeah, so it's still stuck in this. Probably need to make it a little bigger, like 0.7. Yeah, so now was the fine tuning. Let me. Oh, of course. It was wrong. Okay. Okay. It was a mistake, not a fine tuning. Okay. Let's see how it will work now. Okay, so it actually following path quite nicely. X and Y, that's okay. Yo, this is POG. Yeah, we should probably improve the the state transition and the behavior during the attack state, but other than that, it's kind of following the path. Probably 0.2 is still too low. Let's keep it at 2.5, like at 0.5. And other than that, I guess we can return these transitions back. Yep. Yeah, you probably don't want transition back to idle, like at all. It feels not great. So I guess we can also remove this, like if the target is visible, then it will go to the chase state, like directly. Don't have to use like chase radius at all. Where's the problem? One of three. Oh, okay, yeah. Hello, fellow comrade. Hello, Stalin. Let's put it a little bit further, like 20 or 15, like 20. Yeah. Yeah, so this is the point where it's last seen. Now it's going to the attack state. Yeah, that feels much better. Let's try this staircase of pathfinding death. Oh wow, it worked. Okay, nice. Wow, this game you're making looks good. I wonder what it would be like when it's finished. It's just a live stream session. I show how to create like a simple first-person shooter with different mechanics in Unigine. Like I'm not making a complete game. It's just demo content. Yeah, let's disable visualizer and see if we can actually play this. Where it's going? Where are you hiding? Feels like it's hiding from me, not chasing. Oh, you're stuck here. I see. Okay, so let's think that this is mostly fine. We need to add 2 more things. Let's actually add more robots. Like we have multiplayer. Not yet. Let's see how we can handle them. And oh no. Can they see me? Oh, here it goes. Quantity beats quality. Yeah, in a way. Here they are. You look kind of like PewDiePie. Nah. Okay. It still doesn't feel quite right in terms of like a complete gaming experience, but for the sake of this demo tutorial, I think it should be fine. We should probably also keep chasing once, even though we still in the attack state. Okay, so the last thing we are going to add is the health actually. So let's create a health component. Public int health. health. Let's add 5. We don't want to do any of this. What do we want to do is to take damage. And is dead means health less or. And here health would be math library, maximum of the health minus damage. We'll clamp it to 0. Okay, so this is very primitive health component, and the bullet, this bullet, what it will try to do, it will try to get the health component, like from the hit object, get component health, and if it's there, that it will take damage from the bullet. That's it. So that way we can do like a friendly fire. We can do a lot of different things. Let's first play with this robot. So here we will add a health component. Let's say, okay, 5 should be enough, and we want to do the same to the player. Actually, it's better, let's player hitbox, and let's make it a little bit bigger. Unigine is the best in the world, in the universe. Yeah, thanks. Okay, so the player and the hitbox should be somewhere there. So when the hitbox hits, we should notify the player. Here. So let's go and grab, let's add a health component here. Okay, 5 should be enough. Okay, let's try. It seems that, yeah, the bullets go through. It's just lag. Just to mark where the bottom is, we can properly set this thing. Let's try one more time. Yep. Okay, so let's also add some sort of a message that I just want to be sure that this hitbox is hit by the bullets. Yep, hit. Okay, okay, good. And another thing that we want to do is we also want to patch the weapon controller from the player. So here, so if we have a hit object, we also want to get a health component from the hit object. And if we have a health component, then take damage. Okay, and in the enemy logic, we will also have a health component. Here. Like so. And in the update logic here, if health if we have a health component and is dead, then we will delete this node. Doesn't work. Oh, I know why. It's because this health component should be on the visuals, because we are intersecting it with the visuals. Let's test it. 1, 2, 3, 4, 5. Yeah. And we should probably do the same thing with the player. We have a first-person controller, we have shoot input, and probably we need some sort of a player logic. Which will do the same thing, basically. And if let's see if it will work. Almost there. One more. No? Why I'm not dying? Oh, I know why. Because I haven't assigned the component. Yeah. Okay. And one more. Yeah. And it crashed, but yeah, that's because we can't just delete the node because we have a player, like game player. Let's set it to null. Oh, yeah, because the player becomes null in the enemy logic. So, yeah, if player null will do nothing. Robot kill engine. Yeah, Russian robot.exe stopped working. Yeah. Okay. One more. No. Ah. And logic line 98. I'm gonna watch till the end of the stream. I have nothing to do anyways. Basically, we are done. So let me just fix this issue, and after that, that will be it. Let's do the proper way. So the proper way should be like another big component game state. And in the game state, we should probably add enum, like I don't know. Game state is probably a bad name for this component. Yeah. Let's do this. Delete this and create another component, and let's call it game controller. And here we will have a enum game state. Here is gameplay. And win, lose. Public game state, current state, game state, gameplay. That's all we need to do. And in the player logic here, we'll just add a link to the game controller. And here, game controller state, game state, lose. And in the enemy logic here, we'll also add it's not the best way to link the game controller. Probably better way to put it as a singleton or something like that. But again, for the sake of the tutorial, This should be fine. Okay, so game controller, if game control state does not equal game state gameplay, will do nothing. Angry robot. Yeah. Okay. And this game won't have any winning conditions. You can only lose. How is that? And here we'll create another node. Let's call it gameplay systems. And here we'll have a game controller. State gameplay, that's fine. For the player, we will add this to here. For the robot, we'll add this to here. Okay, let's try the game now. 1, 2, 3, 4, and the last one. No? Yeah, finally. Nothing's happened. We can probably add a UI or something like that, but other than that, yeah. So this is how you can manage the game state. This is how you create the like simple AI, and with the ability to use the navigation mesh for path finding. Yeah, that's how you do it. Let's have some fun. I think the left gun of the robot is more accurate than the right. You are probably right, but I think the issue is with the hitbox itself, because I think it's not properly aligned with the camera for some reason. It should probably have a different translation and rotation. But yeah, I guess the problem is with this hitbox. Let's try to survive and actually not lose. Angry robots. Guys, have you played Cradle? It's made with Unigine. Yeah, it's made with the Unigine. Oh my god. I'm surrounded. I'm stuck. Oh, they're here. Yeah, they should probably aim better. Other than that, yeah, it's starting to look like a simple game. At least I have a loose conditions, and yeah, I have a simple AI. Yeah, I was helping the Cradle devs with the tech questions. Yeah, those were the days. Winning condition should be if no enemy nodes exist. You win. Yeah, probably. Not in this stream, I guess. But you get the idea, yeah. We can extend the game controller and put a list of enemies here, and once there will be no enemies, it will be a win condition. Yeah. Alright, so I guess that will be it for today. Okay, do you have any questions? What should you name this? I have no idea. If you have an idea for the demo name or game name, yeah, feel free to, yeah, don't hesitate to tell me. The Red Bots, yeah, Unigine Super Shooter. Oh yeah, yeah. Robot Gulag Slayer. This doesn't look like Gulag. Too shiny, I guess. Okay, any more questions before we end this live stream session? Because it took like many 3.5 hours. Wow. Did I just miss the stream? Yeah, but don't worry, it will be like the record will be available. It's insane engine has perfect render lighting techniques. Yeah, thanks. Published game on Steam? Probably not. Recommended UI system for engine that can be used with the community version. You can stick to built-in widgets, or if you have a look at the C# third person demo, let me show you how it's done in this particular demo. It's not like a ready to go out of the box solution, but it might give you an idea how to approach the UI if you don't want to use built-in widgets. Fun evening, thank you. Thank you for coming. In this third person platform demo, there is a, where it is? UI. Yeah, so there is a UI plane, which is a like there is a game over panel, which is a node reference itself. And once you go inside, basically it's just a plain, a bunch of plain meshes and specific node called object text. And there is a like on some of these planes, there is a specific component called UI element. It's not built-in component. It was made specifically for this demo, but you can grab it and adapt it to your purposes. I guess that might be if you're familiar with Unity UI, for example. I guess that should be familiar to what you experienced previously. Why don't you speak in Russian? So yeah, I can read Russian, but I can't. I can also talk to in Russian, but the stream is in English, so sorry about it. I know like there are a lot of you guys, a lot of Russian guys who are watching these live stream sessions, and yeah, you always wondering why the live stream is in English, because it's for the international audience, so that's why. Will there be more tutorial live streams on Unigine? I guess. At least there will be one more, and then we'll see. So we need to actually polish this first-person shooter demo. When will you have your next stream? Not sure, probably in February. Good English. Good English, strong accent. Why don't you please translate it to me? I can't quite understand English. I guess after the live stream session you can just enable the closed captions and try to understand translation from my Russian mind to my bad English, and then to bad Russian capture, like auto-generated captions. So yeah. Do you know about Elbrus Russian CPU? Are there any plans to make it work on Elbrus? I know about the CPU, I know about its architecture, but know nothing about how Unigine works on that CPU, so don't know. Okay, let's do a few more questions and then we will end up the stream. Oh, actually, I didn't show you how I didn't show you about the UI. Let me just quickly show you. So this is the third-person shooter demo, and this is the UI setup. So yeah, you ask about the how you can make a UI system. So this is a custom tailored UI specifically for this demo. Again, it was made with intention to for the newcomers that are familiar with Unity UI, for example. So because like this is the same geometry and these are like the components. This is specifically made component for this demo. Okay, any more questions? I hope I will visit your next live stream. We'll see. Thanks for coming. Okay, I guess that's it. Yeah, sorry it took too long, but yeah, we finally managed to finish the most important part of the first-person shooter, like the how to approach the AI, how to approach the navigation, and how to work with the what's the pipeline for the navigation mesh. Stumbled across your stream, love it. Can't wait for the next one. Thanks. Do you guys have Discord? Yes, of course. There is an official Discord which you can join and ask questions, and yeah. Sometimes I also answer some questions on this Discord. So if you have any live stream related question, you can ask me directly. Alright then, I guess that will be it for today's live stream session. Thank you guys for coming. In the next stream, I guess we will wrap this up and we will polish things. We will add sounds. We will do better animations. What else? We can try and do stuff like recoil and more like a UI, like I don't know, like red flashes when the player was hit, something like that. We'll see. Again, thank you for coming, and I will see you in the next live stream session. All right, bye.